The Fukushima Daiichi nuclear power plant is a disabled nuclear power plant located on a 3.5 square kilometer site in the towns of Okuma and Futaba in Fukushima Prefecture, Japan. The plant suffered major damage from the magnitude 9.0 earthquake and tsunami that hit Japan on March 11, 2011. The chain of events caused radiation leaks and permanently damaged several reactors, making them impossible to restart. By political decision, the remaining reactors were not restarted. First commissioned in 1971, the plant consists of 6 boiling water reactors. These light water reactors drove electrical generators with a combined power of 4.7 GV, making Fukushima Daiichi one of the 15 largest nuclear power stations in the world. Fukushima was the first nuclear plant to be designed, constructed, and run in conjunction with General Electric and Tokyo Electric Power Company. The March 2011 disaster disabled the reactor cooling systems, leading to releases of radioactivity and triggering a 30 km evacuation zone surrounding the plant. The releases continue to this day. On April 20, 2011, the Japanese authorities declared the 20 km evacuation zone a no-go area which may only be entered under government supervision. In November 2011, the first journalists were allowed to visit the plant. They described a scene of devastation in which 3 of the reactor buildings were destroyed. The grounds were covered with mangled trucks, crumpled water tanks and other debris left by the tsunami, and radioactive levels were so high that visitors were only allowed to stay for a few hours. In April 2012, Units 1 to 4 were shut down. Units 2 to 4 were shut down on April 19, while Unit 1 was the last of these 4 units to be shut down on April 20 at midnight. In December 2013, TEPCO decided none of the undamaged units will reopen. The sister nuclear plant Fukushima Daiichi, 12 kilometers to the south, is also run by TEPCO. It also suffered serious damages during the tsunami, especially at the seawater intakes of all 4 units, but was successfully shut down and brought to a safe state through extraordinary actions by the plant crew. The reactors for Units 1, 2, and 6 were supplied by General Electric, those for Units 3 and 5 by Toshiba, and Unit 4 by Hitachi. All 6 reactors were designed by General Electric. Architectural design for General Electric's units was done by Ibasco. All construction was done by Kojima. Since September 2010, Unit 3 has been fueled by a small fraction used in the other reactors. Units 1 to 5 were built with Mark I type containment structures. The Mark I containment structure was slightly increased in volume by Japanese engineers. Unit 6 has a Mark II type containment structure. Unit 1 is a 460 MW boiling water reactor constructed in July 1967. It commenced commercial electrical production on March 26, 1971, and was initially scheduled for shutdown in early 2011. In February 2011, Japanese regulators granted an extension of 10 years for the continued operation of the reactor. It was damaged during the 2011 Tohoku earthquake and tsunami. Unit 1 was designed for a peak ground acceleration of 0.18 grams respectively. All units were inspected after the 1978 Miyagi earthquake when the ground acceleration was 0.125 grams for 30 seconds, but no damage to the critical parts of the reactor was discovered. The design basis for tsunamis was 5.7 meters. The reactor's emergency diesel generators and DC batteries, crucial components in helping keep the reactors cool in the event of a power loss, were located in the basements of the reactor turbine buildings. The reactor design plans provided by General Electric specified placing the generators and batteries in that location, but mid-level engineers working on the construction of the plant were concerned that this made the backup power systems vulnerable to flooding. TEPCO elected to strictly follow General Electric's design in the construction of the reactors. The plant is on a bluff which was originally 35 meters above sea level. During construction, however, TEPCO lowered the height of the bluff by 25 meters. One reason for lowering the bluff was to allow the base of the reactors to be constructed on solid bedrock in order to mitigate the threat posed by earthquakes. Another reason was the lowered height would keep the running costs of the seawater pumps low. TEPCO's analysis of the tsunami risk when planning the site's construction determined that the lower elevation was safe because the seawall would provide adequate protection for the maximum tsunami assumed by the design bases. However, the lower site elevation did increase the vulnerability for a tsunami larger than anticipated in design. The Fukushima Daiichi site is divided into two reactor groups. The leftmost group, when viewing from the ocean, contains units 4, 3, 2 and 1 going from left to right. The rightmost group, when viewing from the ocean, contains the newer units 5 and 6, respectively. The positions from left to right. A set